Hi, I am Ashish Kare and I am presenting on the topic speech signal analysis using digital filters. My group members are Akash, Prathamesh and Sagar. Let's talk about index. I will go through all these points throughout this presentation one by one. Now let's start with the introduction. We know speech is one of the important way of transferring message, that is for communication, and we know the importance of better communication. And to serve the purpose of better communication, speech processing is required. And here for speech processing we are using filters. Filters are basically used to reduce the strength of unwanted signals and to improve the quality of required signals, that is it removes the noise and uh, improves the quality of important signals, that is the required signal. Here it mainly classified into two types, the analog and digital filters. In digital filters we are mostly focusing on filters because they are capable of performing different specifications by most effectively, like uh, like uh, uh, flexibility, portability, and storage and maintenance is also easy in the digital filters. Here we have designed and implemented FIR and IR filters using multi-rate signal processing. These are some of the papers which we have gone through, and then what is the need of the study? We know the importance of communication, and in that digital filters are important for the speech processing purposes. So to improve the to for improvising the communication system, we need to know that the signal processing is happening, how the signal processing happening, what are the different processes and components are included in it. And should also have the idea about the filters, how they are working, then different types of filters, the IIR filters, FIR filter techniques, and uh, different windowing methods and uh, all those things. So this is the research design. Firstly, the noisy signal is divided into two frequency subbands using downsampling by factor of 2. Then, various filters like FFT, WHT, and DWT are applied to the noisy signals and it's divided into subbands. Here in the paper, they have applied three transform for on the noisy signal, but we are tried to apply only FFT transform for noisy signals and its subbands. Then the low pass and high pass FIR filters are designed and implemented using windowing techniques, and also IR filters are designed and implemented using Butterworth and Chebyshev filters. Finally, the quantization is performed on the filter coefficients of signals and it is subbands. Then the performance of digital filters are measured by calculating signal to noise ratio, which is nothing but the 10 log 10 normalized signal power divided by quantization noise power. And by the ratio, we are concluding that the filtering technique is most suitable for designing digital filters for speech processing. Then, what are the research questions like? What is the speech processing? Types of speech processing? What are the processes including digital speech processing? And what are the different devices filters used for it? Then, data collection. The voice sample is taken for analysis of speech signal from the TIMT, that is Texas Instrument and Massachusetts Institute of Technology database. In the paper, they have taken the database from here only. So we have taken the same database for the analysis purpose. TIMIT database was compiled using 630 speakers, and each speaker spoke 10 utterance, giving a total of 6,300 sentences. Here, this is the link from where we have taken this database. Then methodology. First of all, we read the speech signal in MATLAB and add adaptive white Gaussian noise to it to make it noise signal. Then noisy signal spectrum is downsampled into multiple sampling rates using sampling rate conversion and treated as a subband 1, subband 2 and subband 3 and so on. Then here they have applied three different transforms, but we have did using only fast Fourier transform. Then we apply fast Fourier transform to the noisy speech signal and its subbands. Then FIR filters are designed and implemented using different window functions. We have used all these five windowing methods, and IR filters are also designed using Butterworth and Chebyshev filters. Then apply these filters to noisy signal and subbands. Then quantization is applied to the filter coefficients. Finally, the performance of the filter coefficients are measured based on the signal to quantization noise ratio. Here you can see in the block diagram the noise added in the signal, and it's a sample by single rate and multi rate. Then filter, then we have applied only FFT transform and given it the filter, that is IR filter and FIR filter. Then performance are measured once without quantization and with quantization for both the filters. Now let's see the MATLAB implementation. First we have read the speech signal. Here you can see the MATLAB code for this reading the signal, and this is the plot for the audio signal. Then Gaussian noise is added into the signal, and you can see the change in the plot, the speech signal. Then we have downsampled the signals, that is we have downsampled noise signal by a factor of 2. Then downsample the subband 1 by 2, and again subband 2 by downsample 2, and subband 3 also downsampled by 2. These are the 4 plots of or 4 subbands. Then FFT of original signal. Then we have applied fast Fourier transform to the noisy, that is the original signal, and then you can see the change in the output. And then also we have applied FFT for all the 4 subbands, subband 1, 2, 3 and 4, and these are the plots for after applying a fast Fourier transform. Then we applied high pass Butterworth filter, and you can see the plot here. Then we apply low pass Butterworth filter, then high pass Chebyshev filter and low pass Chebyshev filter. These are IIR techniques. Then we have applied FIR techniques, that is first Hamming window for both high pass and low pass filters, and then for Hanning window, Blackman window, rectangular window and Kaiser window. From all these plots and all these techniques, we have concluded that we have known that in FIR technique, Blackman high pass filter provides high SQ and ANR, that is signal to quantization noise ratio, than other windowing techniques. And in IIR Chebyshev high pass filter provides high SQNR than the other techniques. So from this we have concluded that in this paper the present filter design and non-reduction, actually this paper presents the filter design and non-reduction, and here's paper are the types of devices which removes the noise from the signal and gives the original information as the output. Here we have understood the two but IIR techniques and FIR techniques. In IIR we have gone through Butterworth and Chebyshev type 1 filters, their responses and characteristics, and same way in the FIR filters, all the windowing methods, that is Kaiser, Blackman, Hamming, Hanning and rectangular. Then after the results, we can conclude that the IIR filter is better compared to FIR filters, and in particular Chebyshev 1 filter gives the sharp responses. These are the selected references for we have used for this presentation. Thank you.